Hello, welcome to my channel. Now we're going to carry on trying to make Connect4. And at the moment, we don't necessarily know where the end is. However, we know some things that we need to do. For example, we need to find 4 in a line. Another thing we need to do is we need for the human to make a move. And we've got a test board here. That's how it looks. So if a human makes a move, let's just call the move. For instance, if you're going to move here, let's call it 1. That's going to be 2. That's going to be 7. Okay. So if they wanted to move at position 1, which is here, what would happen is this counter would drop down and that would be a legal move, 55. Here, it would drop down, 20 would be the legal move. Here it would be 57. This isn't a proper board, as you can see, because let me just make it a proper board. In fact, I won't. It's not going to be a proper board, but however, it will drop on 22. That's going to be legal. 23 is going to be legal. 24. So what it's going to do is, when the human makes a move, it's going to put the chip where the human. For example, if I say I want to move at number 1, if I press 1 and press enter, it will drop a chip at 55. And if it was this column and I press 1, it will drop it at 20. So we need a function that does that. Okay? And it's going to do it the same as a lot of other functions. I'm going to paste it in and I'm going to talk about it. So what it does is, it's got this variable called legal and it sets it to false. And in fact, it takes, I'll take what it does. It takes in a board, it takes in a square, and it takes in the side, as in yellow or red. Okay? So it sets legal to false. It sets index to the square. Okay? So for example, if it was going to be here, let me think. Yes, this is going to be the human. This is going to be used for the human move. So what it's going to do, it's going to, because it's going to be the human's going to always move on one of these squares. For example, it's going to be 1, 2, 3, 4, 5, 6, 7. So when the human wants to move, he's going to press 1. And even when we connect the game up, this is the 9 board. So if I do this sum, I'll do a little bit of maths here. And I'll show, oops. If I take this number, 19, and I do mod the board width, which is 9, okay, what do we get? We're going to get 1. If I do 28, I'm going to get 28. What am I doing? It's also, I've done the wrong thing. I've done the wrong thing. 28 is 1. That and thing, I think is and, but anyway, it doesn't matter. If I do 46, that's going to be 1. So that means all things in this column. And remember, we're not using the internal board. As I said at the start, when we're using numbers, for example, like now when we're using numbers, most of the times we're going to be using the outside board numbers. Okay, remember, I'll change that back. Let's just change this back to, okay, so that's a little less confusing. So what it's going to do is, it's the same here. If I land on 29, and I do 29 mod 8, mod 9, that's going to be equal to 2. So even if we done the AI, even whatever we done, we can have the game. We can click here, 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 here. It's going to be turn 1. So all we need is a function and we're going to call it make move. And then when the human does a move, it's going to always be 1, 2, 3, 4, 5, 6, 7 for the reason I explained just now. Whether it's on the whether we do it in the GUID or whether we do it in the console, it's always going to, because of that, it's always going to be between 1 and 7. It's going to be something mod 9. Okay? So what it does, it's always going to start on one of these squares. Okay? So because of that, it's going to do legal equals false, index equals square, while legal equals false. Okay? So the first thing it's going to do is index plus equals board width. So what that means is, whatever the board width is, it's gonna start here and it's gonna automatically jump down to here. Okay? So it's not gonna do that. So it's gonna start from here. It's gonna automatically jump down to 1 square with that. And ignore that first square, okay? And then what it's gonna do then is, if board index plus W equals empty continue. So what it's going to do is going to start here, then it's going to see if that's empty. If that is empty, it's going to continue. Continue means it's going to ignore everything here and it's going to come back to here and check if legal is false. And legal will still be false. So what it will then do is index plus equals W. So index will get incremented. So therefore, now it will be on here. And it will then do the same thing if board index plus blah, blah, blah equals empty. So therefore, it will check if that's empty, and then it will keep doing that. And then eventually it will get to 46. And it will say if that is equal to, and it will continue. And then when it gets to, finally gets to 55, and it gets to this line, if board index plus, so that's the index, it will be on 55, board plus W, that's 64. And it's not equal to empty anymore. Right there. I've said that all wrong. I'm going to start again. Or if I'm not going to start again, board. Yeah, if it's equal to empty, it continues. But when it gets to 55, it's not equal to, when it gets to 55, it's going to check that square. And that square is not equal to empty anymore, so it's not going to continue. What it's going to do, in fact, is set, it's going to set board index equals side, and then it's going to do legal equals true, and when it comes back to here to do the while loop, it will break out of it. So what this would actually do is it's going to make a move on the board, okay, as the function's called. So in this case, if I'd done it here with 1, it will make a move with 55. If I'd done it here, it will make a move at 20. If I'd done it here, 5, it will make a move at 23. Okay? So what I'm going to do is I'm going to test it to see if it's making moves properly. So I'm going to do the side equals red. Let's first try it with 1. In fact, I want to see where it makes the move without having to do print board. So what I'm going to do is I'm going to add a line to it. So what that's going to do, that's going to just tell us, that's just going to tell us which square we added. So in this case, it's going to be 55. Can you see? So added something to 55. Now if I do print board, can you see added 1 to 55? Now if I do that again, make move 1, it's going to add 1 to 46. Can you see? If I print the board, let me just widen this out a bit. If I print the board, can you see now I'm going to add 1. I'm going to add 1 on 4, which is here. Let's just test it. And that 31 is not empty, so it's going to add it to 22. So that worked. And if I print the board, can you see that? So as you can see, I'll do one more test with 3. And I'm going to try yellow. So that's adding a yellow to 3. And it should add it to 57. As you see, that worked. And I've been printing the board anyway, so. And as you can see, that's worked. So I'm going to get rid of this line before I forget. So this function is now making a move. And it's using, it's working just how it would on a real board, as in it will keep dropping. And then when it's not empty, then it will stop. Okay. Now another function I need to make, and the computer's going to use this. What we need to do is we need, for instance here, it's a similar function, but with this one, what it's going to do is, what's it going to do? We need to know the legal square, okay? So how this is going to operate? It's going to only look at these. It's going to be similar to that. It's only going to look at these, and if it comes here, it's going to give out 55. In fact, let me just reset the board. How does the board look now? I think the board should be reset. Yeah, the board's been reset. So what I'm going to do is I'm going to paste it in and explain it. So it's similar to the other one. It's always going to start here at the top. And it's going to start at, for instance, let's just say it started at 1. And it could start at any one of these. First thing it's going to check if the board square plus, so it's going to start here and it's going to check that square. It's going to check number 10 straight away. If it's not empty, it's going to not do anything else, because obviously if that square is not empty, then there's no legal moves. So it just returns -1. So this function, when it returns -1, that means there's no legal move on that square. Okay? So if it gets past that line, it's going to do let legal equals false. It's going to do let index equals square. Why legal equals false? So what it does is, once it gets past this thing here, the first thing it does is it's on this index will be equal to 1. It's gonna increment it, so it's gonna be equal to 10. And then it's gonna check that square to see if it's empty. If it's empty, it's gonna continue, which means continue means it's gonna ignore these and come back to here. And check that if these are false, and then it's going to keep doing that. It's going to keep doing that, and then when it gets to 55, when the index is 55, eventually, if board plus that, so it's going to check that squared equals empty. So it's not going to be equal to empty at this stage. So it's not going to continue at this stage. It's going to do legal equals true. It's going to come back here. Legal is going to be equal to true. So it's going to come out of here. Then it's going to return the index, which is 55. Okay, so let's test it. Computer's going to use this as well. The computer's going to use this. The AI, I should say. Board. Let's try it with 1. Can you see it was doing 55? So what I want to do is really I want to use this to find all the legal moves. However, I'll split it up, so that therefore it's going to look at this column. So all I have to do is loop through these 7 squares, and then it will find all legal moves. If I do 2, that should return 20 as the legal move there. And I'm going to do 2 more. I'm going to do 3. That returns 57. I'm going to do 7. And that should return 25 as the legal move. Okay? So what this function would give me is, all I have to do is loop through them 7 things, and it will tell me all the legal moves in this position, as in, so I'll be able to get to position and say, tell me all the legal moves, and I run another function, and it will use this legal move, and it will tell me 55, 20, 57, 22, 23, 24, and 25. Them are the 7 legal moves in that position. And then, once I have the legal moves, then I can use it for something else, which you will soon will see in due time. Okay, so in this video we created 2 functions that we're going to need. One of them is make move. Okay, and that's for the human. When he makes a move, it will drop it down, and that will make the move for the human. The other one is the computer. Okay, the computer needs to know, it's going to have a position, and the computer's dumb. So the computer just needs to know every single move that can be made in a position. So that means we're going to give it that position, and it's going to say, how many moves can he make? And what it's going to do is, it's going to look at every single move that can be made in that position. It's going to get an evaluation for that position, and it's going to find the best move by doing that, by brute force. That's what the computer is going to do. So that's why we have to find every single move. Okay, I'm going to complete this video now. Thanks for watching. Okay, bye.